I think it did it. All right. Hello, everyone. Welcome to WasmCloud Wednesday for the first spooky WasmCloud Wednesday of the year, since we're officially in October. Let me go ahead and get the agenda shared while we're here. We've got a bunch of demos and ecosystem total updates today. It should be a pretty fun one. So without continuing to blurb, I think we can go ahead and get started. I'm going to be doing a demo on the Go developer iteration, or the developer experience developer iteration loop, the testing framework that we have built with Watch, which is a WebAssembly bridge, the language guide that we've been using for Go, and Go component testing and debugging. So there's a whole lot there, but I just want to set the stage for you. I am a Go developer that's coming to the Wasm Cloud ecosystem, and I want to give out the new stuff, the latest and greatest that we have. I want to give it a try. So what I have locally is like Visual Studio Code. That's where I usually do my development, and I've got some Go tools there. And just before the community call, basically what I ran through on our developer guide under the Go language guide, under components, I gave this a read. And some of this, just as an editor's note, is going to make it into our Wasm Cloud Quick Start. But having language specific guides here on the documentation is something that Eric is kind of pushing forward on the doc side. So I really appreciate this, Eric. I basically ran through this set of instructions to set up the baseline for this demo. So the different projects that we're going to use that you'll see in use with this is Wasm Tools Go, which is a project hosted by the Bytecode Alliance, which contains many different utilities when it comes to using WebAssembly with Go, which includes an updated WIT bindgen, updated tools for inspecting components in Go, etc. We have the component SDK Go, which is completely optional for doing component development, but provides some really nice wrappers around WASI HTTP and WASI logging, and the common imports for standard capabilities for WebAssembly components like key value and messaging and things of that like. And then we have a bridging framework, like a WebAssembly bridge that we've shortened to WAJ, that allows us to generate some native Go code to act as a bridge between the WebAssembly component interfaces to use when you are writing tests. So this guide details everything that you need to do to get started here if you wanted to replicate this. But we start with the existing TinyGo template. We essentially replace that code with the new Go component code. And then we can use both the WIT bindgen Go and the WAJ tool to generate bindings for a test. So that kind of sets the stage for where this demo begins. I believe I was just sharing. I think I need to reshare. So let me give you my VS Code window. So essentially that's what I've done. Like I've gotten to this point, it's just been copying, pasting code, and all is good. So I want to show off some of the new tools that we have, some of the things that we're releasing in Wash and in these different WebAssembly or in these different Wasm Cloud frameworks. So if we take a look at this implementation of the component, it looks pretty clean. There's an init function, which essentially does the translation between a WASI, or it does the implementation of a WASI HTTP transport for Go's HTTP or net HTTP library. And so all I implement here in this handler function is using the net HTTP types of a response writer and the incoming request, which is super nice. So I could use existing code that was already using these abstractions. But the way I'm going to launch this is not by running washup and washapp deploy, which is what we did before. You'll actually see on the left that there is no WADM manifest for this app yet. What we can use instead is this new utility, you saw this proposal in WashDev v2, the updated WashDev experience. And so what this actually does is this builds the WebAssembly component. We just reuse what Wash build does. It starts WasmCloud and Wadm and NATS, all the local infrastructure for running a WasmCloud host. And then it does what we can do with Wash Inspect. If we take a look at if we take a look at the WIT of this component, this is actually a surface where we can see all the functions that a component is importing and exporting. So Wash takes a look at this component. It sees that the only capability that isn't satisfied by Wasm time in this case, like our underlying runtime, is HTTP. And so this detects that HTTP server is a dependency. It actually creates a Wasm manifest on the fly based on this requirement, and then starts the component and opens up an HTTP listener for me to use. So I see that I built this component and I ran it, and I can access this at localhost 8000. So I see hello world. That's great. So WashDev is a multifaceted feature that we have for Wash. But the very first thing that it does is allows you to build your component, take a look at the component's WIT and see what dependencies, what infrastructure it needs at runtime. And then it will create that declarative manifest for you. So this just by itself is awesome. Like this would be miles ahead of our current experience where you run two commands where you run one command. So twice as good, right? But WashDev doesn't stop there. So this is actually the piece that WashDev covered before, where we're essentially watching all of these local files. So if I say hello world from community here, as soon as I save this in VS Code, we can see that WashDev starts rebuilding the project, which would use TinyGo under the hood to build to a WebAssembly component. Something that we've talked about during WasmCloud in our previous WasmCloud Innovation Day is that now TinyGo can build directly to the WasIP2 target. This landed in TinyGo 0.33. So it's super nice. We can kind of use the standard tool chain here. But now, if I send a curl to my component or my HTTP listener, we've actually reloaded the component live out from underneath the here in the WasmCloud application. We just reloaded the actual component itself. Oh, that's not how curl works. So if I just continue to curl this, for example, I can go back to my original state where I save and reload the component. And then basically what this does is it tells WasmCloud to stop the component, and then Wadum will automatically bring it back up. So this is what I think would be a great new entry point for any developer on the WasmCloud side, because it just allows you to get right into writing the code, whether it's Go or Rust or JavaScript. The WashDev works off of the built component to create that manifest. And there's been a lot of experimentation to get us here. So this is great. Now I can see that using WashDev, I've developed my component and it's all working as I expect, right? I want to have a hello world message. I want to make sure that I'm getting a successful HTTP request. And now my component is done, right? So I can go ahead and exit out of all of this. I can exit out of my current developer loop. And what this does is actually just cleans up that manifest entirely, stops all the infrastructure, and then, it's a completely ephemeral dev session. So one thing that I did do from the documentation was create this hello test. And, there's a little bit of setup with the slog handler. But what we're doing here is using the generated bindings from Waj for HTTP to actually create native Go code that is very similar in implementation to the WebAssembly runtime implementation of HTTP. So we can actually run native code that can then be plugged in with our Go native code in this component, and we can run this test just using Go. So we're just going to be running Go code. You can see that we're using Waj the project as a test runner here. This is the thing that's making sure to wrap this properly. But I can run Go test, for example, or I could even click on run test in my IDE. So this is super nice. This is weird. I ran my component and I saw that it was giving me a hello world and that was all working with curl, but I'm actually getting a 500 and that's super strange and maybe this is happening because of some library that I'm bringing in or whatever. So if I was a developer who's writing this, I may want to enter a debugging flow and see how this works. So I actually ran a test on my component. Let's use the VS Code support for breakpoints here to make sure that I can see what happens in my application. So you can see I'm declaring a variable, just like a local foobar struct. Let's rerun this test in debug mode. So this is actually working in the with the Waj project and the WasmCloud component SDK. I'm executing my business logic exactly as it's written as native Go code instead of here as a component. And I can check out my HTTP response, and I can see that okay, my HTTP status code is 200. So that's really where my test is failing. So I can step over a couple lines. You can see I've got some opaque function that I'm calling here that I just imported from some library. Let's see what that's doing. So we can step in, and then of course, we can start to see the problem here. As soon as we are working, or as soon as we call this function, we are writing the 500 status code to my HTTP response. So even though I'm giving back a payload that's successful, it's not a 200 response. It's not what I expect from my test. So I can come in, I can comment that out and remove my breakpoint, and then I can actually run this test and see, okay, great, this was successful. So there's a lot going on here in the experience. The wash dev piece is something that'll work with any component to run that developer loop. The set of Go tools that we have here really makes the component development experience feel like just writing native Go code, and in the end, that's all we're executing is native Go code. So we have in this test some helpers basically so that you can use the net HTTP package to create an HTTP request to call your components function. But other than that, the other bits are what you've seen from Roman and Lucas in past demos, where we're essentially creating this glue to bridge the WebAssembly code here to native code. So what that means is we have this really nice new hot reload experience for WasmCloud, this development experience that is just setting a higher bar for what developers can do. And then from there, you can use some of these new libraries to write Go tests to assert that your component is working the way that it's supposed to. If you see any problems, you can, because Waj is compatible with Delve, you can use your IDE to run through a debugging flow, like stepping exactly through your component's code. I think that there's plenty more to talk about there, but I don't want to monopolize any more time. So do folks have questions about this flow for Go? Awesome. Well, I think that
Sorry, I do one. I was trying to find a button to raise my hand.
yeah, Masood, go ahead.
This is great. Just a quick question about the experience of debugging for Rust. Is that similar in VS Code?
So right now, that's something that Rust does have a different style of debug symbols or different kind of debug symbols than Go does. There is some support for dwarf debug symbols, executing within Wasm time. And I think that Waj can also be extended to support debugging components in Rust, but it doesn't actually work the exact same right now. But that is the experience that we're targeting. We just started with Go.
Okay, thank you.
Yeah, I think just to maybe wrap that one up, I just want to thank everybody who has been working so hard on the WasmCloud side, both in the WasmCloud component side, the WasmCloud library side for getting this kind of Go testing piece working. Everybody who's working on the TinyGo team to push, some on our side, tons on the TinyGo side to push out WasP2 as a target. It's a huge help, and I think I think we iteratively get closer and closer to this experience where you are just writing native XYZ language code and then turning that into a component to run it. But you're getting to use all the standard, language tools for debugging and running and testing. And that's incredibly nice compared to the previous.
How how much work's gonna be to add support for async interfaces when that comes out?
It's a good question. Um, I don't think I have a full enough context there, but Bailey is here. Bailey, you wanna? Oh yeah, Roman is too. I don't actually think I have the expertise to tell you how much work, but
Hi. Um, for it'll be Roman's problem and this library called Cabby-ish. And I think from the perspective of you as a user, like what are you gonna see? It's gonna be totally transparent to you.
Yeah, well, that's great.
Yeah, but generally should be the same. Should be the same as it is right now because we're really just re-exporting stuff from Wasm time. So as long as if Wasm time has it, then we just re-export it.
Okay.
I don't expect there to be too much difficulty. Maybe only for custom interfaces. Yeah.
Oh well, yeah. Well, I was just wondering because I think does Go. I haven't done Go in a few years, and I don't think I ever did async Go. But I know Go makes it pretty easy to do. It doesn't use the colored functions. Like you can wrap an async and a sync, and stuff like that. So I was thinking it'd probably be pretty easy in Go, but less easy in Rust. But I guess hopefully that'll all get figured out in Wasm time. So yeah. Nice to know it's Roman's problem. Roman, don't go anywhere.
Colin, so your question was really around like when native async support comes to the component model, how much more effort will that be to support in Go/Rust? Oh, you're muted.
It told me in very small type that I was muted. No, okay, yeah, I don't want to rabbit hole on this, but if you're already gonna have to support the different debuggers, like the different dApps, and then and that's hard, and then you've got to support for dApp plugins, and then you got to support async on top of that. Didn't know. It seems like a lot of work, but it's great. It should be worth it, but it's a lot. Could be a lot. I mean, how many different Go just uses C style? It doesn't use like TypeScript. It doesn't use like the JavaScript stuff, right?
Yeah,
Debugging symbols.
yeah.
So all the LLVM languages should be pretty similar.
Yeah, I think that generally falls under like dwarf debugging. Go uses like Delve, which I'm not intimately familiar with how it's different. I think Roman could give you a better answer. So Roman, just jump in. But yeah, go for it. I was just gonna say that the I think that's why there's so much uplift from, kind of bridging from the component to the native code, because as soon as we can get just native code running, then the native tools can take over, continue to work from there.
No, it makes sense. It's a good approach. And it's what I tell people. Like, what about debugging? And it's like, well, usually you just run it natively, and then you get to work, and then you see if you can get it to work in WebAssembly. So it makes that story. It's the same story, but it's a better story. Yeah.
So the trick is for Watch at least, for TMS, right? That we don't actually support debuggers. Like we don't do anything in particular for
Right.
debuggers, right?
Yeah.
We actually kind of on the host side or like the runtime side, we just pretend that we are a host and we pretend we speak canonical API. So
Yeah.
what we need, so basically what actually happens here under the hood is that we just have implementation of canonical API, which is canonical API-ish because it have native endian and native address size because it's not 4 bytes, WAS32, but it can be like 64-bit.
Yeah.
Likely is. And so by doing so, we can just reuse all the existing with binding functionality, like Go binding or Rust binding or any other binding, because all it does, right, it calls some C function and it just gives the data in a particular shape. And so on the other side, in this watch side, we then can just decode the data and we know what that other thing calling us expects to get back. And so we just allocate whatever memory we need to allocate to just write that data back.
Yep.
So yeah, so basically there's essentially what we need to do then to make this all work is we need to implement this canonical API-ish layer, which would essentially is just like by the spec, right? And then just give that function, give those parameters to WasmTime and get results back from WasmTime. And the rest is handled by this existing tooling.
Right. So what's the challenge then for porting to other languages in general? Based on that.
None, actually, it's really just the binding part. So for example, for Rust, with binding, will now for native code generate just step out panics for each Wasm import. And so if we were able to not do that and instead just call watch runtime, you're done. You have this whole support. That's true for any language. So it's actually a very small integration work you need to do to actually enable this.
Okay. Well, sounds good.
Yeah, on that component or on the Go language guide on the WasmCloud site, we've got some like preliminary information for Wedge and all the bindings there. But I think there's more information that we have in like draft docs to like really talk about what piece is doing what. The code is actually very I wouldn't expect anything else, but the code is fairly simple to reason about if you look around in the Wedge repo. So I would recommend just kind of poking around, especially at like the HTTP bindings. Those are surprisingly easy to kind of reason about. Mahir, I think you had a question. I want to make sure that we kind of time box my session by the half the hour because there is another demo. But your question was around what about Wasm adoption in big code bases? Would you like to elaborate a little bit more there? I don't know if you're in a space that you can come off mute, but yeah, curious what you're about your question.
Yeah, I'm present here, Brooks. I'm actually asking about I'm actually excited about the Wasm ecosystem, like how it has been adopted in the industry, like, cause I think it's currently a sandbox project, right, or not, in the CNCF ecosystem. Am I right?
WasmCloud is a sandbox project. We have applied for incubating, and we should be hitting that fairly soon, around the CNCF status.
So my question is basically around, like, is it been like adopted by some big tech giants, or it's just undergoing like the trial and testing, like we do in labs or some sort of stuff like it's like still in like early stages, or like what?
Yeah, I think that's a great question, and I can see where Liam was going at in the comments in the thread. So I know that Liam pointed you towards the upcoming WasmCon conference, and why this is a really great resource for your question is you can see many different industries and companies that are adopting not just WasmCloud but WebAssembly in general as a technology. The KubeCon, WasmCon is a great place to see things like that. So I would recommend checking that out. On our webpage, you can also see we kind of pick a couple of case studies that we recommend. We have a few cloud native live sessions where people have talked about adopting WasmCloud in their companies. We have a couple of case studies on the CNCF blog as well that you can take a look at. But just to give you an idea, no, this is not just a project that like a hobbyist sandbox project. We're seeing adoption across a wide range of industries and size of companies from little startups to Fortune 100 companies.
Sure, thanks.
Yeah, thank you for your question. All right. Well, happy to try. I'll try to send some of those links in the chat here, but I want to make sure that we move on for the rest of the agenda. So next on the list for the community call, if I go ahead and share it here, we actually have Lachlan who's going to do a demo of a WasmCloud LLaVA app. So Lachlan, what is that, and what are you showing?
Yeah. So let me chat. Mahia, you're not muted at the moment. Let me share my screen here and we can take a better look. We can work out which one it is. Yes, this is the one. Okay. Y'all can see that all right?
Yeah, that's good.
Cool. So, what we've been doing is we were trying to we actually did a variation of this demo in the WasmCloud Innovation Day, where it was effectively slightly different, but what this demo aims to prove is that you can build similar applications with the same components without too much rework. So actually, I'll go through what the existing one was first. This is a sort of rough outline of how the application works at the moment. We've got a UI client being provided by some UI assets, and those UI assets then load in the browser, and that browser client talks to this router. In our vision, it actually ended up being a component itself, a component that, or rather, it's not a component. It is a provider. It's just not the native WasmCloud one that we built. It's a custom implementation of the HTTP router contract. And what it does is it passes requests on to the various different other components that live within this application. So the idea is that you upload an asset, that asset is passed on to this image handler, it's analyzed, and then the results are stored in the Postgres database, as well as uploading a resized version of the asset to a blob store provider. And then all of that information is updated inside of this task status handler, which is responsible for updating that or fetching the status from the Postgres database. So let me show you what it actually does. So in this instance, we're using the validation, the image upload to basically, let me start that one again, where it's to validate whether or not you've got a valid ID. So in this sense, it's sort of a faux banking app where new user has signed up, they've got an account, but they haven't necessarily finished the verification steps. So here we're uploading an ID document. This is very clearly not an ID document. So hopefully if everything's going well, it should upload, resize, and then fail. So that's all good. But then the other part is if I use a valid ID document, you can very clearly see that this is a valid ID document. Then it should analyze and success. So we have verification complete, and it does actually work there. So the idea is that, yeah.
We just to let you know, we can only see the ID and the picture in the little preview, which I think is
not sharing the profile. Yeah, gotcha. Yeah, okay. So I don't know if I can actually, let me see if I can bring it in. Should be able to. So this is the not a real ID. And this is the definitely a real ID. Now, behind the scenes, obviously, that's not a real ID. It's not a valid looking, not exactly what you would want it to be. But the prompt that I have is pretty straightforward. Let me actually switch to VS Code here and we can take a look at some stuff. Nope, wrong one. There it is. You can see the WasmCloud space demo here. Cool. So this is the manifest here. And we got some, this is the structure of the application. So a couple of components in here. This is the image analyzer component. So this is the component that's responsible for taking the image and passing it on to the AI model. And this is the prompt. So respond only where the Boolean does this image contain an identification document. Now, anyone who's done any sort of prompt engineering will say that this is not enough information for this prompt to be successful, which is why I can give it SpongeBob's ID and it comes back with, yeah, that's SpongeBob's ID. So ideally you would change that, but it demonstrates the purpose. All that I had to do to change this, the previous one for the space demo was, it was looking for pictures of boats. So all that we had to change here was the prompt. Does this image contain a boat, or does this contain an identification document? And the component itself didn't change. The prompt that gets passed into that through the config has changed. So yeah, we were able to quickly reuse a lot of this application, but with a completely different front end and a different prompt to be able to yeah, make use of stuff that we've already built. I don't know if anyone wanted to ask questions or if anyone's got any extra input there, or Liam. I don't know if Liam wanted to talk more about that one, but yeah.
How big's the Wasm component for the LLVM?
Good question. It's technically, it's just an HTTP proxy. So it's pointing locally to the LLaVA API. But there is another version that we are working on, which does include a model, or rather it's a provider that points to a model. So we're not bundling the model into the component itself.
Colin, it's only 126K. Now this is leveraging LLaVA, and if you look in the LLaVA upstream, there's actually dozens of different categories of modules that you can use. Now, one of the things that's not solved out of the box here with LLaVA is multi-tenancy. So you could solve that very easily by spinning up multiple modules, multiple instances here. There is an LLaVA project that does give you multi-tenancy for LLaVA. So I believe a provider for that would be very straightforward because it just shows up as an HTTP instance. But Brooks is running this here on his local MacBook using the GPU. We have run this in public cloud GPUs as well. In our experience, we had a great experience with Google. Not only were the GPUs very inexpensive, but you could also pair it with a variable size machine here for the multi-tenancy and the cost savings for anybody that wants to experiment with this. Right now, both of these demos are closed source, but Cosmonic will be submitting them to the WasmCloud repo here shortly. We just need to get them tidied up a bit, and we think they'd make great iteration points. We're going to build out a couple of this style of demo that all line up for various industries. We have one for space, space themed, one for financial services. We have a few other ideas that iterate, and then there'll be some common components here underneath the hood that are interchangeable between them all. Brooks, you have a question?
I have a comment, but Masood, you were in there, so you go for it.
So my question is about what we heard on the Innovation Day from Bailey about WasmCloud support. You know, a main use case for me for the WasmCloud platform is machine learning related work, right? And that is not only limited to LLMs. So I was wondering that what would be the attitude if someone like me as a contributor tries to bring in WasmCloud as a Wasm Cloud provider, as a Wasm Cloud first class provider?
Yeah, great. Go for it. You know,
Because she was talking about
you wanna talk?
security and sandbox and those, and I wanted to know that, you know, we kind of in agreement that this sort of work can be done to the product, or, you know, for security reasons, it's not the right time.
I mean, if it shows up as a provider, it's optional and people can self-select into experimentation or usage. So, you know, the more the merrier. It's Big Ten.
Yeah.
Exactly, that's the trick. WasmCloud does have some portability concerns, but because you're proposing to write it as a provider, our providers are meant to take advantage of hardware. Like that's the whole design behind it. So, the what would motivate me to do one route or the other is which ecosystem or community I'm trying to take a like, you know, plug into. I think that the LLaVA community is vast and growing, and that's why I'm pretty geeked about it. WasmCloud also has a ton of folks involved, especially from Intel, and being able to take advantage of the work that they're doing is probably a pretty big advantage as well. There are, you know, different approaches, but I think performance-wise, you probably will either see the same performance between the two different approaches. Although I think you can probably eke out some more better perf by using something lower level like what the WasmCloud API.
Thank you.
Yeah, thank you, Masood. My comment, which was small, is really just that, like in this deployment case, Lachlan, you're running, you're kind of running everything on local, but in a case where we're running something in the cloud, right? Like there's a lot of cloud instances that don't have a GPU, but like in a superpower of WasmCloud here is you can specify your workload to run alongside on the GPU instance for the image processor, the one that needs to interface with LLaVA directly, and then the rest of the application can run, you know, just somewhere else. And then you know, is that kind of the idea here?
So
Yeah.
maybe we need something about you know, kind of, you know, the equivalent of Kubernetes node feature discovery.
I think that through, yeah, the way that we tackle that today is just all through host labels. You know, that's something that you can configure the host when you start it. That is kind of a much a very lightweight way to do that, like feature not discovery, the opposite of that. Broadcasting, you know, basically saying this host has this feature. Yeah.
Right. Okay, thanks.
I would say that Lucas and Eunice would be better served to talk about how the backend is actually deployed and how we got it running on the cloud, because they were instrumental in making that happen. Lucas in building it and Eunice in getting it out there. I don't know if y'all are on or available, but yeah.
I can help. Anything specific we should cover?
No, I just wanted to see if you had any extra insights into the app or anything more specific about where it runs or how we built it. But yeah.
Yeah, I think an interesting call out here is that the UI itself is being served as using Go embed. So we build the UI, all the static assets. Then as we compile the components, the whole UI is being added to the component. So this pretty much allows you to ship all the dependencies for the UI in one go. Just one pattern that we're playing with.
Yeah, great. Okay, I wanted to make sure that I kind of cut us off there because it is Lachlan, thank you so much for coming on and doing and showing the demo. But I thought Taylor just had a Wackage update. I didn't know that Taylor had a Wackage demo. So Taylor, I think we all want to see that. Can you just set the stage really quick about, you know, what Wackage stands for, I guess.
Yeah. So in the beginning, just kidding. I'm not going to go that far back. So you've probably heard me talk about several times an update, especially over this past summer. Well, summer for us Northern Hemisphere folks. That we were working on a tooling with OCI and then a tooling for the Wasm environment called we call it Wackage, WKG, Wasm package tooling. And this is a way to basically be able to manage all the dependencies. Now, all the dependencies and publishing and pushing and everything around packaging for the WebAssembly ecosystem. So there is the Wackage CLI, but continuing in our tradition of what we do inside of the Wash tool is we basically embed all of these same developer tools just inside of it, so it's wrapped in one nice experience. So what I'm about to show is the integration of this Wackage tool with Wash and what coolness it allows you to do. So let me demo that. It is a terminal demo, but it is still fun. Okay. Once upon a time, there was a cute little KV component, right? Now, I got Brooks to shake his head. So here in this KV component, what we've had to do before, and actually let me compare what it looks like. Let me go up to Blobby and show you what Blobby looks like. So if I look at Blobby, I have this massive like deps folder, and it's this like blob store. It has every single interface in there, and then it has like each thing, and then you have the steps.toml and the steps.lock, and then like this the deps.toml, if you've never looked at it, is just an arbitrary like, hey, here's the name of the thing, and here's the URL. This is basically Roman created this a long time ago as a stopgap because there was no way to fetch all of these things. And so it's just this like, here, give me a tarball and I'll fetch it for you. And or a directory. And so this is what you were doing. So you had to have a separate tool. It had to be pointing at like specific tarballs or releases to be able to get this down, which doesn't really work when you're talking about versioned interfaces. So that's what we have now. But the world we're looking at now is a little bit different. So right here, you'll see this is what the new world looks like. You'll see that there is still a WIT directory, but there ain't no deps present there. I'll explain this wackage.lock file in a second. But inside of here, what's nice about Wasm, especially with interfaces and WIT, is if we look at the world here, the world tells us exactly what our dependencies are and which versions we're using. So we don't need a dependency lock file. We don't need any sort of other type of like file to do this. We just need to be able to say, okay, what's the world? What's doing this? So this is very similar and related to WashDev, and obviously gets picked up automatically by WashDev, which runs the build process here. But what you'll notice now is I can actually ignore. So in my get ignore, I can ignore the deps directory here. You still need a deps directory. We're actually hoping to be able to condense that down further in the Wasm tooling in the future, that you don't even need that. It just gets packaged into one giant, here's my representation, with nested packages and stuff. But what we're able to do now is say wash build. Oops, sorry, let me do the proper version. Building, this is hot off the press. It's on my branch and the tests are passing and I need the PR reviewed, and then there's some other stuff. I'll follow up on that in a second. But essentially what happens now is I can say wash build. Oops, I accidentally. That was dumb on my part. Okay. I think I might have modified the file when I wasn't looking. Okay, so we wash build. And you'll see, okay, well, that's magical. It starts building. Everything should finish here in a second. Our favorite pastime of watching Rust build. Okay, perfect. So now it built. So how did that magic all happen? Well, underneath the hood, wash build just fetched those dependencies for me, dropped them in there, computed them from the WIT file. So there's no extra dependencies here. You can actually fetch this with a new subcommand that's wash WIT. But generally, if you just run wash build, it'll package these, it'll pull down all the packages for you, put them all in there, and then lock them. So if you look at the what? I have no idea. I might have done something dumb when I was testing. Anyway, so this is actually normally a TOML file. It just has the hashes and everything pinned like you'd expect. I don't know why it's thinking it's a binary file. But anyway, so that's what this tool does. What are we waiting on to get this released out? Well, I need to get this PR out and done. And then once this PR is out, I'm making sure all of our interfaces are pushed up to OCI. So they'll all be available. And then once you do that, you're able to pull those dependencies. Then what we'll do is add those to the Git ignores. We'll keep all the old dependencies around for people who are on an older version of Wash that don't have this in there yet. So you'll still be able to use those dependencies that are basically embedded in there. And then in a few versions, we'll actually just remove all the deps directories and you'll be able to pull it down. Now, the nice thing about this package tooling is that Bailey was that Grandma Bailey asking for it bigger?
Yeah.
Okay. Hold on. Oops. Okay, yeah. As far as it'll let me go. So anyway, there's the depths that we were seeing right there. So what will happen is all of this integrates in with the ability to support private tooling as well. You're able to configure this and like point at private registries. You can use local dependencies and local overrides as well. You can specify a wackage.toml. That file is not required. It's there though for you to be able to override and even like say no, I know what I want, pick this version. I mean, that's probably not the smartest thing to do, but it does let you do it because people like their escape hatches. So that's in there. You're able to decorate it with additional metadata and other things as well that get put into the component. But right now, this just basically does that for you. So all this tooling is standardized across things. So at the bare minimum, people are using config files. I know that Lucas is working on like Go, making sure it reads the same config files so that it pulls from the same locations that Wackage does. For languages that don't have this yet, they either embed Wackage with them or they can do a step beforehand that fetches the dependencies. And like Wash can do this for you as well. So that is kind of the next steps here. Brooks has a question, or someone near Brooks.
Yeah, this one was me. I have two questions. What's inside that the package.wit now? Then like when you pull down, WASI key value, I'm used to seeing like atomics and store and that structure with wit depths. Is it just kind of condensed here?
Yes, it's all slammed together into a single package. Because when you separate it out, that's essentially what happens. Like underneath the hood, it just gets smushed into one big thing. So this is just one giant representation of said wit altogether, including its worlds.
Okay, nice.
You can also, with the tool chains, output this in a binary format, but some of the wit bindgen stuff doesn't support that yet. But these are getting pulled down in their binary format and outputted back into text.
Hey, it's me. So Taylor, you said that like in the wit world, your components are declaring all of the dependencies there. Like, you can see exactly what you need, what version, all that stuff. How do you go from that to it materializing locally? Like, where do you pull it from? When
So
you
these
see like WASI CLI.
Yeah. So when you're doing this, it's going to automatically do some mapping. So what happens is actually, this would be a good time to bring up some package tools. 1 second. I'm gonna switch shares. Yeah, that's the one. Okay. So there is a config file that's fully documented at the Wasm package tools thing. This is the config file that's shared. Same with the lock file that's shared across any language. And this maps by default, the WASI registries are mapped to where the WASI things are stored, which is inside of the WebAssembly thing. And so you have those default like fallbacks that are in place. for WASI, but then we also, inside of Wash, we specifically add the WasmCloud one in for you if you haven't configured it inside of your config file yet. So if you don't have like the WasmCloud namespace set, it'll basically create an entry in here that it doesn't get saved to disk. It just gets done every time you load it inside of Wash. You get a like Wasm, it'll say WasmCloud, and then it'll be wasmcloud.com. And then there's some, for public registries, it does mapping. You can actually see the well-known file if you know where to look for it, which you can figure that out by.
Can you zoom in a
looking
little,
out here.
Taylor? Sorry. Grandma Bailey is watching. We need big text.
Big text. So right there, like this allows you to do all the kinds of overrides. So for example, for an internal registry, like for a team where they might not want to put like a well-known file that helps things redirect, you can actually just specify that metadata inline right here. And then you're able to also specify configuration for your OCI, or if you, even if you're like fetching from local things, you can pass the config you want inside of there, so that way people can have their own custom like pull tokens, you know, with their proper permissions or whatever that will deny access to certain things or allow access to certain things. So you're able to put those things in here without too much of a problem.
Sorry to leapfrog you here, Colin. So it's just because what Taylor was just talking about. So this would happen like if you have like a registry proxy or like a mirror or something, this is where you can configure it. Just be like, instead of pulling from GHCR, pull from this mirror.
Yes. And it's
Cool.
specifically for that. So you could remap. So I know a common thing that's likely to happen here is, especially when you're talking to like big companies, I mean very large companies with strict security requirements. So you think about like banks, think about telcos, those kind of things. They often have their internal reflected registry. It's often a copy of the upstream things that everybody has, but it's been vetted and or signed by their security team. And because this is OCI, you can still, like we've mentioned before, the reason why we've always used OCI is it still integrates in with all your other stuff. You're using ChainGuard, great. You're using like any like things like Wolfie or any of the other tools that are out there to validate things, you can still use that within OCI to make sure that it's the right thing. But here, what this will do is you could then say, oh, WASI is actually mapping to like internal.acme.corp or whatever. And then that you can put a well-known file there, or you can put this metadata in here. And then you can edit this file technically programmatically if you want to as well, and then dynamically generate this. So if you're using internal developer tools or things, you could also just insert these entries in for developers. You could wrap the token fetching and stuff and insert that in. Like the whole idea is that the config file is meant to be globally used. So if you switch from using, once again, everything you just saw here is completely possible using the normal Wackage CLI. In fact, we still publish some of our stuff with the Wackage CLI right now. And it's using the same config file for both of them. So if you've configured it, and it works for Wash, you can still use it just with the Wackage CLI as well. So that's like a key thing here. We never do anything proprietary here in the Wasm cloud ecosystem. So this is just taking that tooling and making it first class support inside of Wasm Cloud. But you can use either tool without it being a problem.
Colin, do you want to ask your question? It's a good one.
Oh, yes. How does this work or not work with cargo component? Which was kind of the way you had to do things. Didn't work with depths because we didn't have registries yet. So it didn't really work at all. But now with Wackage.
So cargo component actually right now uses Wackage under the hood.
Okay.
We actually took all this resolver stuff that does this from cargo component and the wit command that was over there and put it into Wackage. And so we haven't updated it yet, but in cargo component, we're going to use the resolver stuff from here and pull out the wit command from cargo component, and cargo component will just be doing this. In the future here, like we've always wanted to do things like add cargo component support to wash build. So it just uses cargo component, in which case, for a Rust build, it won't. We'd have to change the logic because right now it runs for anything. Because this will work. I'm still working on pushing the interfaces for providers as well. When you run wash build, it'll pull down your wit, and then you'll be able to use that wit that's in there. But
so that's kind of like wash dev a little bit. If it's going to pull providers, except it's going to have to pull
No, it's not going to pull providers. It's just going to pull
Oh.
the plain WIT, the same WIT dependencies. So that's all that's happening here. And it'll work the same way because it's still just using the WIT directory. So all, like cargo component will be added. We'll get that support, eventually down the line here. But the nice thing here is that this can then work for any language inside of WasmCloud, even if their like main language tool chain doesn't have it, because we'll fetch the dependencies, then run the build. Or run, like with Go, we run the Go generate step for you inside of Wash build. So we'll do the same thing with any other language. But I mean, other languages are already starting to adopt this, like C#. So we'll continue to see this increase in adoption, is my guess. Okay, there were a few other questions that I'll try to race through. Jonas was asking if Wackage works without a config file. Yes, it does. You won't be able to connect to everything you want to, like WasmCloud, but if you're using plain Wackage. But with Wash build, you don't even need the thing there to get at least the core dependencies from WASI and WRPC and WasmCloud. It's all set up inside of Wash build to be able to do that automatically. Now, the rest of the config file, you mentioned there's some things that don't matter. Honestly, the only things that don't matter to you are probably the work themes. Everything else will probably come up at some point, depending on your use cases. So I think that, because a lot of this is actually relatively needed. So the preferred protocols are just here because we do support multiple protocols. Ooh, sorry, it's hard to do big. And so that's what that information is. Anyway, it's generally fairly straightforward. Most people won't have to do this for like the general use case. They'll just be doing things like this. Okay. I think that was all the questions. Anything else from people? Back to Brooks.
Thanks, Taylor. Well, then I guess this should probably be released in either the next or the next Wash version, right? It'll just be the Wash dev or Wash build standard.
Yeah, I'm trying to get it out as soon as possible, just working through figuring out why certain things aren't working yet, but should be done soon.
Well, then I think, yeah, it sounds like there's going to be a lot of updates to our examples over the next couple of weeks. So everybody keep an eye out for that. I know that people have their own projects that they're working on locally. So we'll make sure to have some documentation on how to, change your, can everybody hear me? How you can change your project from, WIT depths to Wackage. I don't think there's actually even going to be a step that you need to take here.
Nothing needed. It actually it wipes out the old depths dir and replaces it with the new one.
Let's go. Okay, so don't worry about that. On the Go side, if you have tiny Go components, there's a lot of changes here to, we're changing bindings generators for components for the better, but this will be changing some of our examples. So if you have an existing tiny Go project, take a look at either Lucas's PR, which is up now, or a forthcoming PR where we update to the component SDK Go to see how they get the best, the latest and greatest there. Just a note, the final thing that I wanted to call out for the end of this community call, I talked about it a little bit last week, just to, give a note that next week, so Wednesday, October 9th, we will be doing the community road mapping planning during the community call. So next week on Wednesday will be kind of a special community call. We're going to, if we have a demo, it'll be really quick, but basically we're going to open up a virtual whiteboard, take the feature suggestions, common issues, and just like general where we can do the most impact over the next couple of months in the community and on the maintainer side on the WasmCloud project. We're going to be putting all that up and committing those to our Q4 2024 roadmap. So I put this discussion out there. I really am not sure if GitHub discussions are a good way to collect this feedback, but I tried to look for something outside of Slack so that it was really easy and accessible for everybody who can access GitHub. But please feel free to leave your comments and suggestions here. I think that, I have some ideas about where I think we can improve the WasmCloud project the most over the next couple of months. I don't sure, whatever. I think that in general, some of the most impactful stuff that we've done over the past couple of weeks, you're seeing today in the community call, the improvements in the standard language tool chains, the improvements in developer experience, the sanding out the edges and really committing to standards for whackage, like pulling wit depths from registries, like all of that integration just makes the whole WasmCloud experience better. So, for some of the feature requests that I'm going to be suggesting for the WasmCloud roadmap, they're going to center around that, really the core developer experience more so than additional features that we may add. I think there's room for plenty. But in the next road mapping session, we'll also talk about, kind of a retrospective of how Q3 went, which is pretty well. We've gotten a lot of stuff done, which is exciting. So, all right, folks. Well, yeah, that is just a call out. Please leave your feedback there. If you don't want to put it out in public, that's no problem. Please feel free to reach out to me or any one of the WasmCloud maintainers on Slack, and we'll get that incorporated. So I think with that, we've gone our hour. So I'm going to go ahead and stop the stream. But thank you, everybody, for coming to WasmCloud community meeting. Wait, where is it?